Welcome back to Spank Ranch Garage. Tonight, once again, we're working on the old John Deere 450B bulldozer. This slop is out of control. So we've got a variety of slop in this blade. It's coming from different sources. We'll just take some baselines here. So, front to back, we've got an immense amount of play just between what I'm gonna call the angle plate and the blade. There's an immense amount of play here. So I ended up losing audio early on filming this, but it does come back. So what we're demonstrating here is through the center pin here where the angle plate meets the C-frame. You got this spacer here. You can see there's tons of slop going on with this. And then when I rock the blade, you'll see there's also play in that center pin, which is all being translated to the angle cylinders. And you can see they're pretty slopped out as well. So you got slop between the angle plate and the C-frame, and then you've got a ton of slop between the blade and the angle plate. So as the angle plate rocks, it actually translates all that force up to these angle cylinders, and they really aren't ever supposed to be exposed to that. So therefore, they have way more slop in them that they're ever supposed to have now. I find it interesting that the side-to-side, or the tilt slop, actually isn't so bad on this. That cylinder and its bushings are pretty good. All that play that you see is actually coming from the center pin, so we're going to fix that. Now here's a look at this blade from the side. I have a floor jack under it. I'm going to lower this floor jack. Watch all this action. Look at how much blade action is happening without the C-frame moving. And then finally, this cutting edge is shot. It's almost into the actual frame of the blade. You can see over here somebody changed this wing at one point, or they couldn't flip it because it wouldn't come off, whatever. But you can see the blade skin here is pretty roached. It's split down the center and it's all packed in. Well, that's enough yakking about this. Let's get this turd off of here. And these blind pins are definitely risky. So if that thing wasn't moving free, you'd be having a bad time. I'm sure we're gonna have some bad times ahead here. Can't be seized if it's slopped the hell out. All right, so that is the tilt cylinder dropped out. So I think we just take these bolts out of these, whatever the hell they're called, and this whole blade should fall right off the front. So that kind of feels like the blade is floating. Oh yeah, she's floating for sure. But our side to side is totally disengaged. Wow, man. This is gonna be saucy. Okay. All right, so that's actually pretty nice. That's kind of exactly what I was expecting. I did order a parts manual for this, but it won't be here until next week, so we're just gonna get into it raw dog. This is this central pin here. This thing's probably 2.5 inch diameter, or what it's supposed to be. It's pretty simple though. I mean, it's just this angle frame. These plates push against the back of the blade, and then this all pivots over this pin. It's pretty obvious here, this pin is walloped, and that's contributing to our up and down slop as well. So I think with this pin, we'll have to do some welding on this to get this to fit better. Otherwise, looking at this, you can see that we have heavy wear up here. I mean, I can almost fit, this notch is almost a finger depth. This rides on that like this, but you're supposed to have full thickness there, which we don't have. You can also see that this thing has like a moon shape to it. So it's skinny at the bottom, thick in the middle, skinny at the bottom. And that's giving us all that rocking that we had. This plate's in pretty crappy shape. You can see that thing's almost knife edged, and it's supposed to be that thick. So I got a lot of welding and machining to do on this. Tilt pin, she's got some wear on her. I think they made a 9/16 bolt fit in these so you can pull them. And that came out real easy because everything's slopped the hell out here. This one's not even a John Deere pin. Nor does it fit into the bottom of the blade frame. It's just kind of floating in the top half here. Oh, she's sharp from hammering. Wow. Not bad. I mean, it's a pin off something else, but it works. So now I'm down to the main pin. I should be able to pull this whole frame off. So this is the bottom of that top pin, the main pin here. You can see this is pretty beat up from all the rocking and slopping. Man, this thing is just walloped. But that looks like a huge castle nut with threads on that. And that is not what I expected. How's that a cotter pin? Great. So that's a monster size socket. I don't got anything that big. And I don't have my parts manual yet, but looking at these pins online, I never saw anything with threads on it. You know, I always figured it was just a pin that's retained somehow. This is a big ass castle nut on here. And this really isn't lining up with what I'm expecting to see. Look at the gap in this thing. I mean, it ain't even using the pin anymore. It's just banging the housing into the ears here. This thing's so shot, and I've been dicking with that nut on the bottom. I think I'm just gonna cut this with a torch. All right, watch your toes. She's loose. Look at this. This thing's totally splayed open and blown out. This bottom bushing's blown out. All right, so looking at the damage here, don't know what it looks like on camera, but this hole is shaped like an Easter egg. And this lip down here, I don't know if you can really see the lip. That lip is the original size. This is what it's worn to. This actually doesn't look terrible. I can clean that up and probably work with that. The eye on this cylinder, oval, baby. What's a little more disappointing is the back end of it is also that way. I gotta draw a line somewhere here of how deep we're gonna go in this machine. I want the blade to be stable in a couple directions, and the first is the up and down slop has gotta go. A lot of that came from this blown out bushing here, as well as this blown out bushing. Right, and the fact that these ears are now spread a little bit, created a lot of up and down. Tilt, I want to be semi-stable. That way when you're cutting into, you know, when you've got more dirt on the left than the right, and I want to lean into it and grade that out, I don't want the blade tilting like crazy. I certainly don't want it flopping back and forth like it was, and we're going to fix all that. I'm confident in that. I am still going to have slop left and right like this. I may fix this cylinder, I may not yet, I'm not sure. This one still has a bushing in it, but it looks like the whole end is deformed. And unfortunately, these blade angle cylinders took a lot of abuse. Otherwise, the C-frame seems pretty stiff, meaning the rear pins aren't too blown out, which is good, because that I really don't want to get into. So pretty much from here forward, I can make an impact, and that's what I'm going to go for. That's something I can actually lift. Look at that. So, all of this happens because components in the front here get sloppy and people don't do anything about it. The angle cylinders are taking the blow of that. I mean, look how out around this is, right? Look how this pin fits. Is this a joke? And you can even tell that this cylinder eye has been snapped off before and re-welded. So I'm probably not going to touch it because it still works, and while it ain't pretty, it hasn't broken off, you know, probably in the last 20 years. But all of that is because this blade is not meant to be flopping back and forth like that. Look at this end bit. This thing is supposed to be like 7.5 inches tall, and it's like 3.5. So we got our money's worth out of that. Mold board survived over here. It's worn, but it's not worn through. They really pushed the limit here. I'm not going to do anything about it. I'm just going to bolt it back together. The new, you know, the new cutting edge will come all the way down to here or so. But you know, this isn't cutting edge engineering. We're not going to fully refurbish this blade. We're actually going to do very minimal to it. Now, our 2 points of wear that I'm most concerned about are, one, this center bore. The pin that actually goes into here, I will machine to fit this nicely. Whatever this size comes out to be after I clean it up, that's what will make the pin to fit it. Now, our other sources of wear on this, obviously these plates, but there's a little more to be addressed. All right, so you got your plates that are all just wallered the hell out. We can fix that pretty easily. What we can't fix that easily is the wear that's actually in this surface here. See this lip here? This lip shouldn't be here. And that actually means the ears of the angle bracket have worn into the face or the rear face of the blade, and I can feel it with my hand. This is not flat. I'm not sure what to do here. I could just leave this. Those surfaces are already mated together. And there's plenty of thickness here. I mean, this is probably a 1/2 inch plate, and we got plenty of thickness. So it's not really a strength thing. And also it's kind of rolled, so it looks worse than it is. But if I machine this, if I machine these brackets really nice, and I machine the front side of that really nice, it may bind at higher angles, and it'll have more play in the middle here, which is not ideal. Amount of work to put this on the milling machine, fill this damn thing with weld, and mill all this flat. I don't think the juice is worth the squeeze on this old dozer. I want to improve the low-hanging fruit. We're not here to make this perfect. We're just here to fix the massive amounts of slop and make this thing last a little longer. So I think I'm going to let this ride, and we'll see after we put it together how bad this really is. .675 is the bore of the hole in the blade. So we're at 231 there. This way we're at 242. On the big end, we're at like 24. So that's where a lot of that play is coming from. I'm okay with that. I think we can build this up with weld and then put it on the mill and bring it back down to that 2.6, whatever the number is for the other one. Now, perhaps the most exciting part is that the main pin here, the one causing most of our slop, these appear to be bushings, and I do not believe they're welded in. They may just be pressed in. So I'm gonna get hammering on these and see if we can knock these out, because this looks like this bore is okay. This one down here, we're pushing it, but the bore might be okay on that one too. If I can make new bushings for this, we're gonna free up a lot of slop here. Yeah, baby. And we're left with a nice round hole, boys. This is huge. Look at the shape of this bushing. I mean, it is work hammered to the max. So this gives me a lot of freedom now, because I can pick my own pin size and build my own bushing. See, these bushings are literally just stressed out, just work hardened beyond belief, hammered for years. This so this thing is all cleaned up to start on the welding to build this material back up. I decided to stick weld this because I need the practice. I got the welding rods for free, and I don't want to put all this wear and tear on my MIG welder. Looks kind of crappy, but that will look better once machined. So the intent was to just take this surface here and extend it out with weld. And I probably have to add a little more along this outside edge here. We've added quite a bit. Right, and that's what we started with. So essentially I'm just laying rod on rod on rod until this builds up higher than this. And then we're gonna take a nice flat end mill and just come right through here and make that flat. Moving right along here, we're all built up on this side, all built up on this side. I got one of the plates done here. So you take a look at this, you look down the edge there, you can tell everywhere is a high spot now, as opposed to a tapered low. Decked off our welded area here. Now I'm gonna hit with the grinder, clean up the edge that rolled over. It's not perfect. We got some low spots, but I ain't worried about it. You saw how bad it was before. This is at least up to dimension now. Makes me feel a little better. I don't like the table hanging all the way over, all this weight on the end of it. All right, I'm gonna call it there. Looks really good. We're a little low here. That's okay though. That's a nice area for some grease to fall into, or maybe some dirt. Got to clean up here with the grinder like usual. Now you can actually see, now that this is flat, it's evident how curved the other side is, but that's bedded into the blade already. We're not getting into that on this project. We'll leave that go. So I'd measured this thickness here. It's close to 1 inch thick in the center, and the actual gap on the blade is about 3/4 of an inch. So we will shim our plates up to actually grab this, because it would be too tight if we didn't, and that's a good thing, and that's where these came from the factory. They had shims underneath these plates, so as this wears, you'd remove shims and continue to, you know, wear through the plate. So now that we built it all back up, we're ready to put shims in again. I don't know if I'm gonna actually get any shims. They're probably expensive from John Deere, so I might just use washers, but either way, this side was successful. Now I gotta flip this thing around, refixture it for the other side. Got the sloppy waste oil heater cranking. And we got a snowstorm rolling in here, so I am glad that we stayed up late last night to get this blade and the angle plate into the shop. Wouldn't want to be working out there right now. We are splitting hairs here. Look how close that gets to the column before the cutter comes off the front here. But we're making it happen. The Bridgeport mill is the most versatile tool you can have in your shop, I guarantee it. If you can dream it, you can make it happen on this mill. All right, this side turned out well as well. I gotta talk to my welding guy. There's a lot of low spots here, but it's going to be miles better than where we were. So that's cool. Lots of cleanup with the grinder. Up the weld on this pin here and machine this down to the size that we need to fit on the blade.
We're cruising right along here. We've come up from 2.3 all the way to 2.66 or so.
And we're only going to 267. I put most of the build up here where this thing was noticeably worn out. It looks really good, but I'm gonna come all the way around this thing, hopefully be up to like 2.75, 2.85, something as a finished welded diameter. That way when we machine it down to the 2.67 number, we should have a fairly good surface finish. It's gonna have some pits and crap in it, but you know, we had a 1/2 inch of slop before, now we're gonna have 4/1000 of slop. So we're making steps, huge strides in the right direction. But you can see how much weld I had to put on the top of this. And I'll be grinding this and coming in here and filling all this. This is just my first quarter here. Alright, so finally, I think I'm done welding on this thing. I mean, it's been an hour and a half straight of welding. This is all the rods I killed. In hindsight, I should have just made a bushing for this. I should have put this on the mill, turned it down to 2 inch, and then made a 2 inch by 2 6/7/0 bushing. Just called it a day. All this welding, what a pain in the ass. It's out of hand, I'm letting go. Oh, don't slide off. She was headed for the hills there. So I am leveling this up with an actual carpentry level. I know that sounds shady, but this is construction equipment. It's going into a hole that's not perfect anyway. So as long as I'm level to the table, a couple thousandths over a foot doesn't matter. Yeah, baby. We're making a round object out of a very unround object. All right, so we made out pretty nice with this. It's back to a round object at least. Now, this is not top machinist quality work here, right? You can see I've got pitting on the low side of this where I didn't weld enough. But the important part is this is where the majority of the wear was on top, so I went really heavy with the welding up here, and really I should have went really heavy everywhere. Maybe I could have even falsely moved this center a little to catch it all in one shot. Screw it. This is 95% good, and that's all she needs. So remember, this thing is just plugging into the hole in the back of this blade, and this hole is not perfect. Well guys, I'm gonna wrap up this part 1 here of fixing the blade on my 450B John Deere dozer. It's the 6405 bulldozer blade, the 6-way power hydraulic. So we got pretty far along with some of the weld repair on the angle bracket and the plates that hold them to the blade. We've got our parts ordered. We kind of know what we need to do, but there is a lot of machining left to get this thing back together. So it's definitely going to stretch into part 2, hopefully not part 3, but I appreciate you sticking with me. I'll see you real soon. We'll get this thing wrapped up and good as new. Thanks for watching Spank Ranch Garage. Talk to you next time.